Cancer is the second leading cause of death around the world. Just in 2020, around 10 million people died from cancer. To put that into scale, this is all the people in British Columbia and Alberta combined. So why is it after investing billions of dollars in research every year, there's still so many people that die from cancer? Well, one of the reasons for that is that cancer is an unpredictable and evolving disease that is hard to treat with one approach. And so we're still looking for new ways to treat cancer and find a magic bullet that can stop cancer growth. So one promising target for that bullet is a molecule called STAT3. STAT3 is a messenger molecule that helps cells receive signals for growth. STAT3 plays a critical role in controlling cell growth, and so its activity in normal cells is tightly controlled. However, in cancer, STAT3 gets overactive and helps cancer cells grow and spread. It's estimated that 70% of all cancers show overactive STAT3. And so if we find a drug that can block STAT3 directly, this would offer an effective treatment to treat cancer and save many lives. So even though we've known this since the 90s about STAT3, we still haven't found any drugs in the clinic that directly block STAT3 in cancer. Could that be because we're using old-fashioned or inaccurate techniques to look for drugs for this target? To address this question, in my PhD research, I'm using novel heat treatment techniques to look for new drugs that target STAT3 directly. So how can we use heat treatment to let us know that STAT3 is being bound by drugs? The technique that we're using relies on detecting the thermal stability difference between a free STAT3 and a STAT3 molecule that has been bound by a drug. Typically, the bound STAT3 would be lower energy or have higher thermal stability, which means that you'll be more resistant to the heat effects compared to the free STAT3. A simple analogy of this is a toaster and two different slices of bread. Picture the bound STAT3 molecule as a frozen slice of bread and the free STAT3 as a fresh one. If we toast both of these breads for 2 minutes, the fresh one would get golden crisp. However, the frozen one would still be soggy. And that's because they have different thermal stability. And so just like the toaster, we're using heat treatment to detect thermal stability difference between a free STAT3 and a STAT3 molecule that has been exposed to different drugs. Using this new approach, the main goal of my PhD is to find new drug agents that can block STAT3 directly. Finding the magic bullet for STAT3 would not just allow us to study cancer biology better, but will hopefully find a new and valuable weapon against the fight against cancer. We hope that using a novel heat treatment technique that is more accurate, we can save many lives in the vicious fight against this disease. Thank you.